Right, this morning we are going to talk about local variable type inference, and specifically whether it's a good thing or whether it's a bad thing. And the reality is that there are places where you can use it that are good, and there are places where you can use it which are not so good. So that's what we're going to go through, some of the examples of how you can use it and how you cannot use it. Right. So the first thing we need to do is to just establish a little bit of background in terms of why we would want local variable type inference. And I think this is one of the really nice things, as somebody who's been involved in Java basically right from the very beginning, to see that after 24 years, we're still adding things to the language. We're still finding new ways to improve the way that it works to make it easier for you as developers. Now, we all know about Java, and we all know that we have classes in Java, and that's how we encapsulate both state and behavior. And when we're encapsulating state, we use fields. And the important thing about that is a field is related to the class and therefore the object that you instantiate. It's part of the object, and it exists for the lifetime of that object. From the point of view of how it's initialized, the compiler will guarantee that there is an initial value for that field. So you don't have to do something. You can if you want, but you don't have to. So something will be assigned to that field. We then have local variables, which are ones that we can use within methods. And we can use them within blocks of code, we can use them within a statement, we can use them within a for loop, all those types of things. But here, things are a bit different. So one of the things that's different is that the initialization is not guaranteed. You can create a variable and not assign anything to it, and the code will still work. Can we just turn the volume down a little bit, please? So that's one thing. The other thing is that the use of local variables within our code can be very cheap from the perspective of the storage, because you can actually put the variable on the stack rather than having to allocate space into the heap. Now, it doesn't always work that way, but often if you're using primitives, you can just allocate the space on the stack, and then when you pop the stack frame off, you reclaim the space straight away. The thing about local variables is that, unlike the fields, often how you use them and the name that you give to them is more important than the actual type of the variable that you're creating. And I'll kind of explain more about that as we go through. But it is important to sort of see the difference between a field and a local variable. Question, obviously, is why would we want to add local variable type inference to Java? Because we've not had it for the last 20-something years. Why do we suddenly feel that it's necessary to do that now? Well, the obvious answer is JavaScript has it, so it must be good. I don't think that's actually a very good answer, because there's lots of things in JavaScript that it has, and that isn't a good reason for having them. But, people are used to having var in JavaScript. And so it's a sort of logical thing that maybe we should add it to Java. But there's more to it than that. If you look at streams, which were introduced in JDK 8, they changed a lot of the way that we do things in terms of our code. They introduced a more functional style of programming. They introduced more type inference, and we'll come back to that again later on. But also, because of this idea of chaining together the method calls, what we effectively do is hide a lot of the intermediate types. And that's really good, because we're not assigning variables to each stage of the process. We can just chain these things together, and we can say, OK, the output from the stream that we call on our list is a stream of strings. But as a developer, I don't need to care about that. I can pass that into a filter, which, again, generates a stream of strings. I can then map it to change the type and create a stream of records. But again, as a developer, I don't care. And then I collect it into a list, and at that point, I get something back, which I actually care about the type. But all those intermediate stages doesn't matter from the point of view of my code. I'm focusing on what the code needs to do, not the types that I'm using in between each stage. What we'd like to do is to be able to expand that sort of elimination of type information to more places in our code. And that kind of goes back to that first thing that I was saying about how the name and the use of the variable is actually more important than the type that we assign to it. We want to see more about how it's being used rather than what it actually is. The other thing with var is it can make our code more concise. So we can eliminate some of the extra stuff that we have in our code, and I've got some good examples of that. But the nice thing is that it doesn't necessarily sacrifice readability. In fact, in many cases, it will actually make things more readable than if we use explicit types. So these are all good reasons for why we should add local variable type inference to Java. Okay, let's start with looking at some of the simple uses of type inference. This is the kind of code that we write now. If I want to create a local variable called userList, and I want to create an array list to store some things in, then I have to do this. I have to specify the type of userList. So I say array list of type string, userList, and then I create a new instance of an array list. And I have to specify array list. And because of the fact that we now have the diamond operator, fortunately I don't have to specify the generic type a second time, but I am still specifying array list twice. If I want to retrieve a stream from that array list, I then have to say stream of type string, stream equals list.stream. Okay, so this is very logical code. It's exactly what we're used to. We can use types as well in other places. So if I want to create a for loop and I want to iterate over a collection, then I can do the same thing, explicitly stating the type of the variable name as being string. Now, that makes sense because we need to know what the type is. The compiler needs to know what the type is in order to guarantee that the code works correctly. And similarly, for the older style for loop, we explicitly say what the type is. So for int I less than 10, I++. All good stuff. What we can now do is eliminate some of the use of explicit types. And certainly in the case of the earlier examples, we can eliminate the double use, if you like. So now we can just say var userList equals new array list of type string. We don't have to specify that the user list is of a particular type. We'll let the compiler infer that for us. From a readability perspective, we're not losing anything because we as developers can easily see that user list is being assigned to a new instance of array list of type string. So clearly the type is an array list of type string. No problem there. We can use var with stream, and we can retrieve the stream from that, and the compiler will know that because userList is an array list of type string, then the stream will be a stream of type string. But that's where things start to get a little bit more debatable, because now we don't immediately see the type of what stream's going to be. Clearly, if the two lines of code that we have there are right next to each other, it's very easy for us to see what's going on. But if those lines are separated by some distance in our code, it may become harder to understand what the types are, and therefore we're sort of losing some of the readability. But we'll come back to that. Similarly, we can use var inside our for loop. And if we want to iterate over our list again, we can say var name over user list, and the compiler will infer string. We could also, if we wanted to, say for var I less than 10, I++. That would infer int. Now, that's immediately one place where I would say you probably don't want to do that. The reason being that int has 3 letters. Var has 3 letters. So you're not gaining anything in terms of the amount of typing that you're doing. All you're losing is the explicit information about what I is. Yes, we can all guess that I is an int, but to keep things absolutely clear, probably in that situation, you just want to continue to use int. But you can use var if you want to. Now, when it gets more useful is when we start to look at things like this. Try with resources is a very useful feature that was introduced a while ago in Java. And what it allows us to do is to put our resources into a set of brackets with the try statement so that we guarantee that when we leave the try block, all of those resources will be closed correctly, or at least the close method will be called on them, even if it throws an exception. But the problem we get is we start to see some issues about readability, because I've kind of separated this out a bit to make it more obvious. But what I'm doing here is I'm creating a buffered reader. And in order to create a buffered reader, I need an input stream reader, and for an input stream reader, I need an input stream. OK. But to do that, I've got 3 lines of code. So input stream equals socket.get input stream, and then I've got input stream reader equals new input stream reader of is UTF-8, buffered reader equals new buffered reader ISR. And it's all lots of words in there. If we use var, we can tidy that up quite a lot and make it easier to see what's going on, because we can simply eliminate a lot of that extra type information, and suddenly the code becomes simpler to read, simpler to understand. Now we can see we've got input stream reader, buffered reader, and then we can look at the right-hand side of the assignment, and we can see exactly what's going on. So something like that is a good use of var, because it tidies up the code and makes it easier to understand. More typing with less typing. OK, now, the important thing about var, I did mention JavaScript at the beginning. It's not like JavaScript. So it doesn't introduce any concept of dynamic typing into Java. When var is used, the compiler will infer the type for you. And that is the type of the variable, and that remains fixed. In this very simple example here, I've got a var name, and I've assigned Simon to it. Because I put that in quotes, clearly the compiler will infer that that's a string. So name is now a string. If I want to, I can change the value of name very easily. So I could say name equals Dylan. It's still a string. Doesn't have any problem, because string is still string. The reference is correct. If I were to try and assign something else to it, so 42, then the compiler will reject that. It will say, hang on, 42 is not a string. Even using autoboxing, I can't convert that to a string. So you get an error. So it's very much statically typed. There is no issue with it becoming dynamically typed. You can't change the type of something once its type has been set. Absolutely the same as the way that Java has always worked. It's just that the type inference happens the first time you create the variable. Final and non-final. OK, so var simply gets the compiler to infer the type. What does that mean? Well, using var doesn't make the variable final. So you can say var name equals Simon, and then you can say name equals Dylan, and you can change the variable. Fine, absolutely nothing wrong with that, because it's not final. Now, some languages, well, actually, you can make something final simply by saying final var name equals Simon, and then you can't reassign the value. Some languages do actually have another keyword that they use. So, for example, you could use val rather than var. And val would indicate that this is something that should have the type inferred, but it is also a final variable. So you can't change its value once it's been set. And I know that when I first looked at the definition of local variable type inference, and there was a lot of discussion about this, I thought, yeah, wouldn't it be a good idea if they did have something like val, so that you could say, in this case, I want to assign a value to this, and it's now fixed. But then the counter-argument is, because we're only using it with local variables, remember, it's not fields in a class, it's only local variables, how often do you make a local variable final? I don't make local variables final very often, because what you're doing is using a local variable within a block of code to manipulate some data. So most of the time, you actually want to change its value through a loop or through some expression or whatever. but you don't tend to make local variables final. So I think that the decision to not have val and simply say, OK, if you really do want to make it final, you explicitly mark the var as final, it seems like a logical choice to me. Action at a distance. Now, this is what I said a little bit earlier on. You need to be careful about how far you have between your code when you use var, because sometimes it can be difficult to understand what the type is that you're getting. In the case of L, where we're assigning a new array list of type string, that's easy. We can see what the type is. If we have S directly underneath that, or maybe separated by a couple of lines of code, then again, it's easy to see that S comes from, actually it should be L.stream, not list.stream, comes from L.stream, and so we know what the type of the stream is. But if you've got a large piece of code, and there's lots of intermediate code before you reference L again, and then you assign using var, suddenly you say var n equals L.getZero, and you think, ooh, hang on, what is L? What does it actually return? And because I haven't got an explicit type there, I'm then going to have to search back through my code and look at where L was defined and say, oh, OK, it's an array list of type string, so what I'm going to get for n is actually a string. So this is one of the sort of guidelines, is to say, OK, if you're going to use var, that's fine, but don't separate things out too far, because it may not be clear what the variable that you're getting in that case is. Jumping variable names. This is sort of the same thing as you have with the try-catch block. And I've created a deliberately obtuse example here where I've used very long type names. And you can see that we've got a lot of kind of letters in there. So there's lots of code there. And it's not really easy to sort of immediately pick out what's going on here. So there's some assignments of things, there's some different types going on, there's parameters being passed into constructors and things like that. But it's really not easy to look at that code and immediately see, oh, OK, what's going on? If we use var, we get the same sort of effect that we had with our try with resources block. And we can tidy things up very nicely, and suddenly we see, oh, OK, the var lines everything up nicely. We can see all the variable names, and it leads us easily to read on the right-hand side of the assignment, OK, we're dealing with a new no object, we're dealing with a new big decimal amount increase object of a particular type, then we've got a horizontal line connection, a constant, and a list of. Again, making life much easier for us and for other developers who want to look at our code. So this is the kind of place where var is very useful to simplify what we're actually doing with our code. Now, there are some edge cases, if you like, of where you can and can't use var. Not everything can be inferred. So here's an example. I want the first 6 primes. And actually, it's interesting because I remember having a discussion with this. I don't think 1 is a prime number, is it? So it's actually it should really be 2, 3, 5, 7, 11, 13. But anyway, I digress. Right, so if you want the first 6 prime numbers, you can create an array, and you can assign the elements to that array using the braces. And we can define the type as being an integer array. That's all good. We could theoretically say, well, OK, why don't we use var for that? And we could say, well, that makes sense, because we've got an array of ints on the other side, why shouldn't we be able to use var and have the compiler infer that the type of the array is an integer array? Actually, that won't work. So if you try and do that, you'll get an error which says it can't infer the type for a local variable, and it says that the array initializer needs an explicit target type. So this is one case where the type inference doesn't quite extend far enough, and so although you would look at that code and you would say, well, clearly it's an array of could be ints, the compiler will not actually do that for you. So in that case, you have to explicitly state the type of the array. There are some other things. types have to be required on both sides. So if you do this, var list equals null, now you would think to yourself, well, I'm assigning something to that, so shouldn't I be able to use var? And the answer is no. If you do that, you'll get error, cannot infer type for local variable, and it says variable initializer is null. The reason for this is because null is a special type. And if you think about it, in Java we have object. Object is the superclass of all other types. Null is effectively the subtype of all other types, because you can have a null of any type. So null doesn't actually lead you into any specific type. So when you say var list equals null, there is no type that is, well, there's no easy way of defining what the type is and inferring it. You could arguably say that it's object. So you could say object list equals null. But the designers of the type inference feature decided no, in the case of null, because it's not strictly speaking an object, it could be an object, but it could be anything else as well. Because that's ambiguous, what we'll do is we'll actually reject that as a value, and we'll say, OK, you can't do that. Again, types are required on both sides. So if you say var list, and then you have a line further down which says list equals new array list of type string, this you would sort of theoretically say, well, I've defined the type and then I've assigned it to a value a little bit later on. But again, this won't work. This is where the compiler will say you can't use var on a variable without an initializer. So when you define your variable list with var, you have to assign a value to it. You can't do it later on and still get the compiler to infer the type for you, even though the compiler theoretically could look at that and say, yes, it's an array list of type string. It won't let you do that. One of the reasons for that is because you could end up with a situation like this. You could say var list equals new array list of type string, and then further down you could try and do something like list equals 42. Problem with that is that if you try and get the compiler to be clever and say, OK, well, why don't we try and assign a type for that, you end up with a problem, because what type would the compiler choose? It could say, well, we'll choose the first one, which is an array list of type string, or we could choose the second one, which is an int, or we could choose one that fits both of them, so we could actually choose object, and then by using auto boxing on 42, we could turn that into an integer object with the wrapper class and still assign that, and we wouldn't get a mismatch in terms of the types. So theoretically, again, you could have the compiler do that. But the problem is, which of those options is the one that should be chosen? So the simple answer is that the compiler won't let you do any of those. When you create a variable with var, you must assign a value to it at that point. Literals. OK. Now, there are good uses of literals and bad uses of literals. All of these are good uses of literals. Now, the reason these are good uses are because there is no ambiguity about what type is involved. And that's quite important. So we can say boolean ready equals true, char ch equals x, long sum equals 0 and L, very important there because we're explicitly stating that this is a value of 0, but a long 0 rather than an int or a short or a byte. And then string label equals foo. We could use var with all of those very easily because of the fact that there's no issue about what type is being involved. When you look at var ready equals true, it has to be a boolean. Var ch equals x has to be a char. Var sum equals 0L has to be a long because we're assigning 0 long to it. And var label equals foo has to be a string because it's a string that we're assigning. So these are all good uses of var. Dangerous uses of var are where the type is not necessarily unambiguous. There might be some debate. byte flags equals 0, short mask equals 0x7ff, and long base equals 10. Okay, so that's all fine. That's Java code that works quite happily. However, if we were to use var with those, that's dangerous. The reason it's dangerous is because when we assign those values to flags, mask, and base, the type that could be used could be more than one type. So in our example, obviously, we were using byte, we were using short, and we were using long. But the compiler in this case will look at all those values, and it will say they are ints, because each of those will fit into an int, and that is the most logical value, primitive type to use for those. So this is where things get a little bit complicated. You need to be careful. If you're assigning a value in terms of a primitive, literal, then you need to think to yourself, okay, if I change that to a var, do I still get the same type that I would expect if I make it explicit? Multiple type inference. Okay, now we have the diamond operator. So we can avoid having to define the generic type parameter on the right-hand side of our assignment. And we can use that with var. So this causes a little bit of an issue, because now we're saying var item queue equals new priority queue, diamond operator. So the diamond operator uses type inference to determine what the type of the generic parameter should be. Now, typically, what we would do, if we're not using var, we'll say priority queue of string, item queue equals new priority queue diamond operator. And the compiler will very happily infer that the priority queue is of type string. But in this case, we're using var for type inference. So the compiler, first of all, has to infer the type of the generic parameter before it can infer the type of item queue. The only way it can do that, because that's the secondary type inference is our var, the only way it can do that is actually by saying that the priority queue is of type object. Now, it could be what you want, so that there's perfectly valid code, it will compile, it will work, but be careful that if you're changing code, and if we think back to the sort of very first examples where we had array list of type string equals new array list of type diamond operator, when we change that to use var, you need to remember to put the explicit generic parameter type back in to the diamond operator. Otherwise, you go back to using object, and that will change the way that your code works. var is a reserved type, not a reserved keyword. So for those of you who came to my presentation yesterday, this is what I talked about as well. var is not a reserved word, which is good, because it means that you can still use var as a variable name, which means that something like this, var equals new value added reseller, is quite legitimate. So there's no problem with that. You can do var. However, one of the things that you can't do in JDK 10, JDK 10, that you could do in JDK 9 is create a class, because this is now a reserved type. You can't create a class called lowercase v var. But I know that none of you would have ever done that, because we don't use lowercase for class names, do we? We're not like .NET. So what you can't do now is create a public class lowercase v var. Could have done that in JDK 9, but you wouldn't have done it. And so that is no longer valid. That won't compile. What will compile, though, is var with an uppercase v. So you could have var with an uppercase v, and that will still work. So there are different ways of doing things. So that essentially the compatibility thing is that you can't create a class called var with a lowercase v anymore. Programming to an interface. Now, this is something that people often do, which is to say, okay, when I assign a value to assign a variable and create its type, rather than giving it a concrete type, I give it an interface. So this is a simple example where I say list of type string, my list, equals new array list diamond operator. very common way of doing things that we use the interface rather than the concrete type, and then we can pass it to anywhere that we want to use our list. Yes, we all do that in many different places. If we use var, then the first thing is, as I said, we have to remember that we have to put the generic type parameter on the other side now. So we can say var mylist equals new array list of type string, because otherwise you get array list of type object. But the type that will be inferred by var is an array list of type string. So rather than it being list of type string that we had above, the inferred type will be array list of type string. Now, that doesn't matter. Polymorphism still works in exactly the same way. Array list of type string is still an implementation of the list interface. So you can still pass it and use it wherever you would have used a list object rather than an array list object. So the polymorphic way of looking at it still holds in exactly the same way. It's just that the inferred type will be the concrete class rather than the interface that was used or implemented for that particular class. Lambdas and var. Here's an interesting thing, you see, because again, what we're dealing with is more than one place where type inference happens. In this case, what I can do is I can create a lambda expression, which is an instance of the predicate interface using the string as the generic type parameter. So I can say predicate string blank line equals, and s is the parameter of the lambda expression, s.isBlank is the body of the lambda expression. In this case, the compiler is already using type inference. It looks at the fact that this is a predicate and of type string, and so we'll infer that s must be a string. But we don't have to explicitly state that. So we can say s is a string, well, s is on its own, compiler will infer that it's type string, so we can call isBlank on string, and that will work. If we try and do that with var, and we say var blank line equals s is blank, that's a problem, because we've lost the information that the compiler would use to infer the type of s. Now we simply have, well, it's something, and we've got a lambda expression on the right-hand side. And the lambda expression has a parameter s, but we don't know what the type of that is, and we can't infer the type of s from the left-hand side, because we would have to use type inference there. So we got type inference on type inference. So in that case, if you try and do that, the lambda expression needs an explicit target type, which means you would have to, even if you try and specify s is the string, then it wouldn't work because the lambda expression itself needs to be defined as being a predicate in order to be inferred from that. So basically, don't use var with lambda expressions. JDK11. Now, JDK11 extended the places where you can use local variable syntax. And it did so for lambda parameters. Interesting. So what does that mean? Well, here's an example of us using a lambda expression. So we've got our stream, and then we're calling map, and we're using a lambda expression to say that the mapping is from the string s to the lowercase version of the string. That all works because the compiler, again, infers the type of s for us. We have a list of strings, so s is going to be a mapping from a string to another string. Okay, that all works. The compiler can do that very happily. What we can now do is we can actually specify var with the lambda parameter. So we could say map var s goes to s.lowercase. You look at that and you go, why would I do that? What possible benefit would there be for me doing that? Because s already has type inference, so why would I possibly add var, which is 3 more characters to type, 4 if you include the space and 6 if you include the brackets. Why would I possibly do that? It doesn't give me any benefit at all. And that's quite true. You wouldn't do that. There is only one place where you would use var in a lambda expression parameter, and that's if you wanted to add an annotation. Because if you want to add an annotation, you have to have a type for the lambda parameter. You can't simply say at not null on s. you have to have the type there as well because of the syntax, the way it's defined. Now, in that case, clearly you could explicitly put string s, but if you had a much more complex type, then you'd end up with more text in there and it could be more harder to read. So in this case, using var simplifies the fact that you need that type in there, but you let the compiler do the same thing it's already doing of inferring the type of s, but it allows the syntax of the annotation to work correctly. Intersection types. So this is one of the really useful places for var. In Java, since Java SE 5, we've had generics. And generics, as you all know, allow us to specify a type associated with another class, but do it in such a way that we don't have to define the type when we create that class. Here's an example of a method. So what I'm doing is I've got a method called getData, and I want that to be a generic method, which means that the types involved in that method, specifically the return type, is going to be defined where I use that method. What I can do here is I can actually use some quite complex syntax, and I can say that the type that I want to return from this method is going to implement two interfaces. That's perfectly legitimate in Java. We can implement as many interfaces as we want. We have multiple inheritance of types in Java. But I must admit, the syntax that they use here is a little bit sort of misleading. So we have T, the generic type, extends, closable, and iterator. Really, it's implements, but they decided to overload extends there, but it should be implements. So T extends, closable, and iterator. And we can define that very easily. The syntax works, it's all good. So we have an object that's being returned, which is of a type that implements two interfaces, both closable and iterator. What it does in there, we don't care. This is all valid Java syntax. Right. The problem is if we want to use that generic method inside another method, which is also generic. So here's a slightly contrived example, but this is what we're trying to do. So we are trying to create a method called firstMatch, and that takes a predicate which has some generic type associated with it, and it returns an optional, which again has a generic type associated with it. What we want to do is we want to use something that we get from getData. So getData is going to return this object which implements both closable and iterator. We're then going to use that within our code. And if we look at how we're using it, we have it in a try with resources block. So in order to do that, we need to implement the closable interface so that the compiler can use that and actually call the close method on it and make sure that the resource is terminated correctly when we leave the try block. We also use it in creating a stream, so we know that to do that, we have to implement the iterator interface. So this is fine. So we have the same thing that we've got before, which is that we need closable and we need iterator to be implemented by this type. The problem is the XXX there, this type that we need, is going to be both closable and iterator of E. But we don't have a way in Java syntax of specifying that. We can specify it in terms of the generic parameters for the method that returns that object, but we can't specify it in terms of a local variable. There simply isn't a syntax that works to say that we have a generic variable here which implements both closable and iterator. You simply can't do it. Which is where var comes in very handy. Because what you can do is this. You can actually say var elements equals getData. And even though you can't explicitly, using Java syntax, describe the type that's going to be returned by getData, the compiler can do that internally. There's this idea of denotable types and non-denotable types. Denotable types are the ones that you can actually describe in your Java code. Non-denotable types are ones that the compiler can understand, but you can't actually express in Java code. So in this case, this is a non-denotable type, but by using var, the compiler says, oh, OK, I'll fill in the details for you with something that you can't represent and make this code work. So in this particular case, it's really nice that you actually make the code work in a generic way because var will represent something that you can't describe in Java code. OK, time for a couple of puzzlers to ask you, the audience, what you think. OK, so we have a piece of code here where we've got a calculator which takes a mask and returns Boolean. And then we've got some long value there, and we return something which we do some bit shifting and ORing and stuff like that. Let's use var. Question is this a good use of var, or is it a bad use of var? So who thinks this is a good use of var? Right, OK, one person, yeah, because you just had to do that just to be different, didn't you? OK, who thinks this is a bad use of var? Of course you did, because otherwise I wouldn't be asking the question, would I? Right. However, the interesting thing is, why is it a bad use of var? OK. So obviously, if you go back to what I was talking about earlier with literals, the value 0x 1, 2, 3, 4, 5, 6, 7, 8 will fit into an int. So the value that's inferred by the compiler will be an int, not a long. OK, that still doesn't quite explain why this is a bad use of var. The reality is, though, that if you put a mask in with less than 0 value, you'll get different results. Between using long, if you pass a mask in that's less than 0, it will return true. If you use var and it infers int, and you pass in a mask which is less than 0, it will return false. So in this case, it's a very bad use of var because it will change radically the meaning of your code. So don't use it in that particular case. Now, if you had the L to force the assignment to be a long, then it would work correctly. But you have to remember to do that rather than just using var. Puzzle 2. OK, so in this case, what we've got is a method which takes a Boolean and another Boolean and returns a list of strings. And what we're going to do is we're going to say, OK, create a new array list, and then we will add foo, add bar, and return the list. Let's use var in that case. And again, so the question is, who thinks this is a good use of var? OK, a couple of people there. OK, who thinks it's a bad use of var? OK, majority of people, still good, going with the idea that I'm asking the question, so it's bound to be no. Again, let's look at why that is. And the simple answer is that we have fallen for the trap, which I have said a couple of times that you must remember, which is that if we use array list with the diamond operator, we forgot to put the fact that it was an array list of string into there. And so now the diamond operator will infer that it's an array list of object, and we'll get an error when we try to compile it, because it'll say that you can't convert an array list of object to an array list of string, and you'll get a failure in your compilation. So again, it's remembering to put that generic parameter into the diamond operator if you take it away on the left-hand side. Third puzzler. OK, last one. Now, this is an interesting one. OK, so we have list removal, which returns a list of integer objects. And what we're going to do is, again, rather contrived example where we create an array list of integers, and we add some numbers to that. And then what we do is we call a method called value to remove. And we'll use var in this case to say that the value of v is something, and what we're going to remove. And then we'll call list.remove of v and return the list. Some other place in a galaxy far, far away, we have this other method called value to remove, which returns an integer. And that returns 3. OK, so who thinks this is a good use of var? OK, a few more hands this time. OK, who thinks it's a bad use of var? OK, yeah, most do. OK, still going with my, I'm asking the question, so it must be wrong. But the interesting thing is why? Because that code works perfectly. There is nothing wrong with that in terms of what's happening there, because we're returning an integer. Var will be inferred as an integer, so v will be an integer, and then we'll call remove of that integer object, and everything will work in exactly the same way as if we made it explicitly integer. So why is it a bad use of var? Well, the answer is that, let's say you have a new intern arrives, and they look at this code for value to remove, and they say, hang on, why are we returning an integer object here? I'm a newly minted Java programmer. I know about these things. We don't want to create an integer object or a wrapper class, because that creates a new object on the heap, and then we've got to garbage collect it. We're returning 3, let's just return an int. So I'll change the code to do that. Now, when you recompile your code with var in it, clearly that will work because var will be inferred from what's being returned from the method, and it will now become int rather than integer. And it will still work. But the problem is that what happens will now be different. Because rather than doing list.remove of an integer, we'll be doing list.remove of an int. There are 2 overloaded methods in list, which both take, they take an int or an object. So that will still compile. It will still work. No problem there. We won't notice an error. But if we do that, the result is going to be, again, radically different. Because if we say remove int, it removes the element at that position in our list. If we say remove object, it removes the first instance of that object in our list. So the result that we get with the first one is 1579, and the result we get with the second version is 1379. Even though everything's compiled, everything runs, we don't see any errors, we get different results. So that's not a good use of var. Right, so guidelines as a sort of set of ideas for how you should use var and how you should not use var. And this comes from a document that was written by Stuart Marks. It's on the OpenJDK website, so I encourage you to go and read the whole thing. But this is sort of the short list of what's going on here. Firstly, it's more important about reading code than it is writing it. Because remember, you're probably going to write that code, you have everything in your head as you're doing it, so you understand exactly what's going on. You give that to somebody else, and they have to understand what it is you've done. Clearly, you write lots of comments, you make sure that your code is easy to understand. But if you're going to use var, make sure that where you use it makes sense from the point of view of things like variable names, from the point of view of where you're using var, how far apart the code is, so that you can understand the type easily. Code should be clear from local reasoning. So again, when you see var list equals new array list of type string, it's easy to understand. If you see var equals n.get something, it's not so easy to understand. Similarly, code readability shouldn't depend on an IDE. You don't want to have to hover your mouse over a variable and say, what is the type of that? Because you should be able to figure it out from the code itself. As we all do, choose variable names that provide useful information. List L is less useful than list my list of people that I need to send a letter to. Minimize the scope of local variables. Yes, that's a good thing because if you're going to use a local variable, you don't want hundreds of lines of code between uses of it. Keep it as small as possible within blocks of code. Consider var when the initializer provides sufficient information. Obviously, when you're assigning to an instance of an object and instantiating an object, that's a good one. If you're just calling a method on something else, it's not such a good use because it's harder to tell what the type is going to be. Use var to break up chained or nested expressions. That's a good example because if you've got like a long chunk of code where there's lots of different stuff going on, using var to separate out things can be very useful, and not having to have all the explicit types in there can make life easier as well. Take care with using var with generics, as we've already seen, and take care when using var with literals. Again, we've seen that, making sure that you know that the type that's going to be inferred is the type that you think it's going to be. Conclusions, local variable type inference is a useful feature. I think there's lots of places where it's very useful. Certainly in the code I've been writing recently, I find that I use it quite a lot, and it makes life quite easy. But with great power comes great responsibility. So do be careful when you use it. Remember, other people are going to read your code later on, and they need to understand what's going on in your code. And consider the implications of where you use var. If it's Simple uses, that's fine. If it's more complicated ones, then think, okay, if I do that, how easy is it for somebody else to understand my code? And that actually is that. So, спасибо. So I have a few minutes, so if there are questions, then either I can take them now or I will be at the discussion area later on, but there's a question there.
Thank you for the great talk. Returning to the null assigning.
Yeah.
Can I cast type explicitly from null and then put result in an inferred variable?
So can you cast a null?
Yes.
No.
Like no.
No. Just don't do that. That's just not a good idea. No, definitely not. No.
And what compiler says about it?
I haven't tried that actually, but I don't. I mean,
I'm very interested.
Yeah, I would have to try that on the compiler to see what it did.
Thank you.
Oh, another question there.
Yeah, thank you for the speech. And my question is about predicates, and why haven't we infer predicates like in map function in stream with var using? What's the difference between inferring predicate and inferring predicate in map function as a parameter of map in stream? It looks the same, but in stream it can be inferred, but
well, yes. So if you're using it in a stream, so if you use a map, then, well, you wouldn't use it with a map. You'd use it with a filter, because predicate is the type that's taken by filter.
Oh, okay.
Map uses a function.
Yeah, you're right.
Yeah. So you can infer the type of the lambda expression by where it's used. So the fact that filter takes a predicate as a parameter means that where you're using that lambda expression, it has to be a predicate. If you're using a map, then the parameter you pass to it as a lambda expression has to be a function or a subclass of it. So that's how you can do the inference for those situations. And then the compiler will use the fact that it's a predicate to infer the type of the parameter that's used in the lambda expression. So they actually rewrote a large part of the compiler to do type inference in lambda expressions explicitly. And with var, because you don't have that information about what the type is because of where it's being used, if you simply try and assign, s goes to s dot is blank, you don't have the fact that it's a predicate. It could be it could be a mapping just as much as it could be a predicate. No, actually, it couldn't be a mapping. Well, no, it could be actually, but you can't guarantee the type of the lambda expression based on the fact you're a var on the other side.
Yeah. Okay. Thank you. So in short, it takes the type of the parameter from the types of lambda from the type of parameter.
Yes. Yeah, so it takes the type of the lambda expression from the parameter of the method where it's used.
Okay.
And then, because it knows what the type of the stream is, it can then infer the type of the parameter of the lambda expression.
Yeah, thank you.
Okay.
Thank you for the talk. And on the slide with about distance in code, you used variable names like s, l, and can we just fix it using more clear variable names?
Yes, and that's a very good point. You see, if you make your variable names more explicit, then you could still get away with using var at a distance, because you can say, okay, if I've got var l equals my list of names who I want to send letters to dot get, then it suddenly becomes clearer as to what's actually going to be returned by that. So yes, in that case, you can get away with that. But if you're using short variable names for local variables, then it could become harder to read. So it's a judgment call.
Thank you.
Пока иду, я хотел сказать, что в 12:32 в зале номер 5 Альфа-банк расскажет про размышления о пайплайне. Поэтому, если вам интересно, бегите туда потом.
Hi, thank you for your talk. My question was, you mentioned that it's not a good practice to store in var kind of lambda expression, but is it as a point because you, as I remember, you used shorten notation when like a type of parameter was emitted, but okay, for pipelines it's like a real thing because we can restore it from pipeline context, but for storing in variable, why don't we use like explicit notation of parameters? We don't need shortened notation in that case because we're storing in variable for usage in future. And we actually like are not bounded with this like need.
Yeah, I think if I understand your question, because it's a little bit difficult, it's just really how the lambda expression type needs to be inferred. So there's nothing wrong with actually assigning a lambda expression to a variable. It's just that you need to make it explicit because the compiler can't infer the type of that.
Yeah, it's the thing. Okay. Thank you.
Thank you.
Thank you for both presentations. My question is about assigning null to var. You told that it causes error, and why can't be assigned null to object?
Yeah, I mean, that is the thing, you see. Technically, you could say, well, you could infer a type of object, and then you could assign null to object. So that would work quite legitimately. There's nothing wrong with that. It's just that because null is considered a special type within Java, and it is not just an object, it could be any other type. So rather than assigning it to object, they decided that they would just not allow that. So it was a decision on the part of the developers. It wasn't, there was a technical reason that you couldn't say, okay, let's just make the variable object and assign null to it. It was that they decided that that was probably safer to not have a type associated with it because it was just their decision in terms of the reasoning behind that.